Hello and welcome to another one of these ADD videos. Today we're going to be looking at ionic compounds. Ionic compounds are compounds that form bonds between a metal and a non-metal, in which a transfer of electrons takes place. Typically, metals will give up the electrons, forming cations, resulting in a positive charge, and non-metals will accept the electrons, forming anions and a negative charge. Together, these are called ions, and they are your charged particles. The periodic table offers us insight on how to obtain the charges. The A groups, the main columns, are going to have 1 through 4 plus charges, meaning they're giving up electrons. And the column number is going to coincide with the charge. For 5 through 8, what you do is, there's supposed to be a total of 8, and if you do the group number minus 8, you get these guys. So in this case it was 5 minus 8. This would be 6 minus 8. And this would be 7 minus 8. Alright? So as a result, we end up with those charges for those columns. Some metals can form more than one charge. They're referred to as multivalent. Okay? Example is iron, and can form a +2 charge or a +3 charge. When naming, we use what's called the stock system, which uses Roman numerals to indicate which one we're dealing with. And there's also a conventional way of naming them, in which we use "ic" suffix and "us" suffix. So this table is available on the website. Oops, sorry. Let's zoom in a little bit. So you can see the symbol, the stock name using the stock system, and the classical name. And the "us" goes with the "us" suffix goes with the lesser of the charge values, and the "ic" suffix, "ic" suffix, goes with the larger. So you can see the ferrous is the +2, whereas the ferric is the +3. All right? So keep that in mind. There might be a couple questions asking you to name stock or classical. There are a few basic rules that must be followed when writing ionic compounds, the first of which is the cations come first. Then we must have the subscripts produce electrically neutral formulas. The subscripts must be fully reduced. And there should be no charges in the finished product. So don't draw any plus or minus signs. So what are the steps? First, you're going to need to figure out the charges. Either use the column fact or the multivalent. Sometimes in the multivalent it gets a little bit more complex, but I'll show you some examples of that and you'll understand how to deal with that. Cross the charges over, then reduce, and then you're done. That's your ionic compound. Okay? So it's also possible to go backwards by reversing the logic. Beware of the multivalent cations, because you can have a few mistakes occur that way. So if you check out a few of the example videos, all this will be clear. Practice, practice, practice as always. I hope I've eliminated any doubts that you might have of your ionic bonds. Thank you and have a nice day.